Okay, now we're going to introduce the half-angle formulas. So that's the next set of formulas on the formula sheet here. If you want a copy of the sheet to follow along with, check the video description. There's a link in there. You can click that link, open this up, print it out, and follow along if you'd like. So these are going to follow from some substitutions and some basic algebraic manipulations from the power-reducing formulas that we introduced earlier. So we have our power-reducing formulas are sine squared of theta equals 1 minus cosine 2 theta all over 2. Cosine squared of theta is 1 plus cosine 2 theta all over 2. And tangent squared of theta is 1 minus cosine 2 theta divided by 1 plus cosine 2 theta. Okay, so the half-angle formulas, they're going to give us formulas for trig functions of half angles. So in terms of just trig functions of regular angles. So like sine of alpha over 2 is going to be this mess here involving cosine of alpha, and so on and so forth. So the idea here is to make a substitution. So what we want to do is say, okay, let's, here we have a theta and a 2 theta, so let's make a substitution. We're going to say, okay, instead of 2 theta, let me call it alpha. So let's say let alpha equal 2 theta. Okay, why are we doing that? Well, because we want to get something in terms of half angles. So if alpha is 2 theta, then divide both sides by 2, and then alpha over 2 equals theta. So now what we're going to do separately in each of these three formulas here, what we're going to do is replace 2 theta with alpha, and then theta gets replaced with alpha over 2. Okay, so again, we're just doing a simple substitution. We're just going to say, okay, I want to take this 2 theta, I'm going to call it something else. I'm going to call it just plain old alpha. So I'm going to sort of lose that 2 behind the scenes. Okay, and then if alpha is 2 theta, well then what do we do with just the plain old theta? Well, theta, if we divide both sides of this by 2, then theta is going to be alpha over 2. So let's go ahead and see what happens with that. So this becomes sine squared of alpha over 2 equals 1 minus cosine of alpha, all divided by 2. Okay, so that's what's happening here. Remember, theta gets replaced with alpha over 2, and 2 theta gets replaced with alpha. Okay. Now, we want to have half-angle formulas for just with no powers here, so we have to take the square root of both sides. Okay, take the square root of both sides. So then we end up with sine of alpha over 2. Okay, that's an alpha on top and a 2 on bottom. Bad handwriting. Equals plus or minus square roots of 1 minus cosine of alpha all over 2. Okay, so we have to be very careful. We have to take the positive and the negative root. Which one are we actually going to use? Well, it depends. So remember, sine of, let's say, beta, we're using alphas and thetas to mean other things here. Sine of beta is greater than 0 if beta is in quadrant 1 or quadrant 2. Okay, for example, and remember, what does it mean for an angle beta to be in that quadrant? It means the terminal side of beta, if beta is in standard position. So if the terminal side of beta is in quadrant 1 or in quadrant 2, then the sine of beta is positive. Okay? So using the same principle, that's going to help us determine which SIGN sign, plus or minus, to take here. Okay? So, and that's actually written on the formula sheets, if you'll notice here. The sign, plus or minus sign, is determined by the quadrant of alpha over 2. So remember, if this angle inside of here is in the first or second quadrant, then it's going to be positive. The sign, SIN sign, will be positive. If alpha over 2 is in quadrant 3 or quadrant 4, then the sign, SIN sign, will be negative number, and we'll take the minus sign, SIGN sign. Okay, so whether this is positive or negative depends on where alpha over 2 is. So be careful, it doesn't depend on where alpha is. Okay, it depends on where alpha over 2 is. So if alpha over 2 is in quadrant 1 or quadrant 2, then it's positive. If alpha over 2 is in quadrant 3 or quadrant 4, then this will be negative. Okay, it depends on where alpha over 2 is, because that's what's inside of the sine function. Okay, it doesn't matter where alpha is. It only matters where alpha over 2 is, so be very careful about that. Okay, and we will see some examples with that later on. So anyway, that establishes this first identity, or first formula here. Sine of alpha over 2 is plus or minus square root of 1 minus cosine alpha all over 2. Okay. Now the formula for cosine is going to be literally pretty much exactly the same thing. Actually, it really is identical. The only difference is this plus sign here, which makes no difference at all, really. And we're still going to use the same substitution. Let alpha be 2 theta. Okay, so we'll separate this here. So then alpha over 2 is theta, and then that's going to give us cosine squared of alpha over 2 equals 1 plus cosine of alpha, all divided by 2. And then we take a square root of both sides. And again, just like before, we have to take a positive and a negative root. So cosine of alpha over 2, equals plus or minus square root of 1 plus cosine alpha all over 2. And again, just like before, whether this is positive or negative depends on where alpha over 2 is. Remember, cosine of an angle is positive if that angle is in quadrant 1 or quadrant 4. Okay? We talked about that a long time ago, that type of thing, where the trig functions are positive and negative. So if alpha over 2 is in quadrant 1 or quadrant 4, then this will be positive. If alpha over 2 is in quadrant 2 or quadrant 3, then this will be negative. Okay? So cosine alpha over 2 is plus or minus the square root of 1 plus cosine alpha all over 2. And we see that is our second formula here. Okay? Cosine alpha over 2 is plus or minus square root of 1 plus cosine alpha all over 2. So that establishes that. Now we have the one, well, there's 3 actually for tangent. Okay, there's 3 here for tangent. So let's go ahead and establish that first one, and then, so this first one is we're going to get that just like we got these 2 here. And then these next 2 are going to follow from algebraic manipulations. So let's go ahead and work on that. Okay, so tangent squared of theta. So a couple different ways to proceed actually, but let's maybe do it just the same way we've done this. Now what we could do is say, okay, tangent of alpha over 2 is going to be sine of alpha over 2 over cosine of alpha over 2, and we could divide this by that, but it gets kind of messy with square roots. It'll work out fine, but it does get kind of messy, and it gets a little tricky with the plus and minus signs. So let's just do it exactly the way we did these 2. Okay? So we'll just use the same substitution. Alpha is going to be 2 theta, so then alpha over 2 is just plain old theta. So then this is tangent squared of alpha over 2 equals 1 minus cosine alpha divided by 1 plus cosine alpha. Okay, so then take a square root of both sides, just like we've been doing, and then we end up with tangent of alpha over 2 equals plus or minus the square roots of 1 minus cosine alpha divided by 1 plus cosine alpha. Okay, so that's one of the first formula for a tangent. Tangent of alpha over 2 is plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. So that's exactly what we have right here. And the same principle applies. Which is it positive or is it negative? It depends where alpha over 2 is. Remember, tangent of an angle is positive if that angle is in quadrant 1 or quadrant 4. Tangent of an angle is negative if that angle is in quadrant 2 or quadrant, or excuse me, a tangent of an angle is positive if the angle is in quadrant 1 or quadrant 3. I don't know if I think I said that wrong. Quadrant 1 or quadrant 3, and then tangent of an angle is negative if the angle is in quadrant 2 or quadrant 4. So if alpha over 2 is in quadrant 1 or quadrant 3, the tangent's positive. If alpha over 2 is in quadrant 2 or quadrant 4, then this will be negative. Okay? And again, we will see some examples with some things like that coming up soon in later videos. So that establishes this formula right here. Now we still have to get these 2 here. Notice these 2 formulas, they don't have the square root and they don't have the plus and minus sign. So actually, if you have a choice of which ones to use, it might be better to use one of these 2. And between the 2 of these, it might actually be better to use this one in the middle here because it only has one term on the bottom, which is generally better. But we'll see some examples of that later on too. So anyway, how do we get these other 2 from anything else? How do we get these other 2? Well, it's going to be done with algebraic manipulations of this guy right here. So let's go ahead and do that. So we're going to need some more room here. Okay, so if we start with tangent of alpha over 2 equals plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. Okay, we'll start with that. Now what we're going to do is inside of the square roots, let's extend the square root. Inside of the square root, what we're going to do is multiply the top and the bottom by 1 minus cosine of alpha. By 1 minus cosine of alpha. Okay. Now what's that going to do for us? Well, let's see. So that's going to give us plus or minus the square root of what happens on the top. So we're really just going to FOIL now, right? We're just going to FOIL. FOIL on the top and bottom separately. So if we FOIL on the top, what we have is 1 minus cosine alpha times 1 minus cosine alpha. So that's going to be Let's actually leave it like that for now. See if we can FOIL that later. Okay, so thinking ahead a little bit, I don't think we're actually going to have to FOIL, so let's not FOIL that on top, but let's FOIL on the bottom. So if we FOIL on the bottom, we're going to have 1 times 1. So first is 1 times 1, which is 1. If we do outer, so FOIL, first, outer, inner, last, outer is going to be minus cosine of alpha. Inner plus cosine of alpha. And then last is going to be plus cosine alpha times negative cosine alpha, so that's minus cosine squared of alpha. Okay. And again, we're not going to FOIL on the top. I was thinking ahead a little bit, we're not going to have to FOIL there, so let's just leave that as it is for now. So this is going to be plus or minus the square roots of, so let's not FOIL, but let's write it like this, 1 minus cosine alpha quantity squared. Okay, let's write it like that. Okay. Now, when we simplify on the bottom, what's happening? Blah, 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 minus cosine alpha plus cosine alpha, blah, blah, blah. So these cancel. That's great. That's wonderful. And we have 1 minus cosine squared of alpha left. Okay. Now, what is 1 minus cosine squared of alpha? So we've seen this several times before. So what that is if we come off to the side, we know cosine squared of alpha plus sine squared of alpha equals 1. So if we subtract cosine squared from both sides, then what we have is sine squared of alpha equals 1 minus cosine squared of alpha. Okay. So 1 minus cosine squared of alpha is sine squared of alpha. Okay. So then what this is plus or minus the square root of 1 minus cosine alpha, whole quantity squared, all divided by sine squared of alpha. Okay. So now notice what we have really is square root of something on top being squared, something on bottom being squared. So if you have something like this, so ignore the square root for a sec. If you have something like m squared over n squared, that's the same thing as the entire fraction just being squared. Okay? So m over n squared. Okay? So even though we have a more complicated expression here, the exact same thing applies. So this is going to be plus or minus the square roots of 1 minus cosine alpha, all divided by sine of alpha, that whole thing being squared. Okay. Now we have a square root of something squared, so they cancel each other out, and we're left with 1 minus cosine alpha all over sine of alpha. So that's where that comes from. Now there is a little subtle detail we have to point out. When you take the square root of something squared, like the square root of x squared, what you really get back is the absolute value of x. Okay. What you really get back is the absolute value of x. But notice out here we have, so you might be thinking, okay, we should put absolute value signs around here. But notice here we have plus and minus signs. Okay, these plus and minus signs came from the original half angle formula for tangent. Because we have these plus and minus signs, this absolute value thing is already taken care of for us. So kind of behind the scenes, this is already being taken care of for us, so we do not have to worry about the absolute values. So if we didn't have the plus and minus sign, yeah, we would need absolute values, and that'd be kind of crazy to have that in that formula. But since we have the plus and minus sign here, this is automatically going to be handled for us here. So 1 minus cosine alpha over sine of alpha, this whole thing could be positive, it could be negative. It just depends on what's happening with alpha. And to a lesser extent, in this case, alpha over 2. But anyway, because we have the plus and minus sign, we don't have to worry about the absolute values around here. Because normally when you take the square root of something squared, you got to have absolute values. But here the plus and minus sign handles that for us, so we don't have to worry about it. So this here, 1 minus cosine alpha over sine of alpha, that equals tangent of alpha over 2. Okay, and that establishes the second half angle formula for tangent. Tangent alpha over 2 equals 1 minus cosine alpha over sine of alpha. Okay, so that establishes that. Okay, now this third one here, we can get it exactly the same way. So remember what we did here, we multiply the top and the bottom by 1 minus cosine alpha inside of the square root. If we do 1 plus cosine alpha instead, okay, we can make this plus and plus, then we can just proceed exactly the same way we did. And we'll end up in the end with sine of alpha on top and 1 plus cosine alpha on the bottom, which would give us this formula right here. Okay, we could do that, or we could just manipulate this one right here. Okay, so let's go ahead and manipulate this one. Just to be thorough, we will go through and show the details. And so doing it to this one here will pretty much be the same thing, so it won't be anything new or different at all, really. Not at all. So let's start with this one we just established. Tangent of alpha over 2 equals 1 minus cosine alpha over sine of alpha. And then what we're going to do is take this one and multiply it by 1 plus cosine alpha over 1 plus cosine alpha. Okay, and then we'll simplify that. So, parentheses, parentheses, be careful about what's happening. So then this is going to be, so on the top, if we FOIL, then what we have is 1 minus, oops, not really foiling, am I? Okay, so if we FOIL, we're going to have first is 1, outer is going to be plus cosine alpha, inner is minus cosine alpha, okay. And then last is going to be minus cosine alpha times plus cosine alpha is going to be minus cosine squared of alpha. And then on the bottom, let's leave the bottom factored, so don't distribute. So we have sine of alpha times 1 plus cosine of alpha. Okay? So then this equals, so if we simplify, blah, 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 plus cosine alpha minus cosine alpha, so those cancel, that's great. So now we're just left with 1 minus cosine squared of alpha divided by sine of alpha times 1 plus cosine of alpha. Okay? And 1 minus cosine squared of alpha, so we already mentioned that, but remember from the Pythagorean theorem, or this Pythagorean identity rather, cosine squared of alpha plus sine squared of alpha equals 1. So if we subtract cosine squared from both sides, then sine squared of alpha is 1 minus cosine squared of alpha. Okay, so 1 minus cosine squared of alpha is sine squared of alpha. So on top we have sine squared of alpha, and then on the bottom we still have sine of alpha times 1 plus cosine of alpha. Okay. Sine squared on top, plain old sine on the bottom. So the sine on the bottom cancels with one of the sines on top. So then what we're left with is sine of alpha on top, and then we still have a 1 plus cosine of alpha on the bottom. Okay. And that actually establishes the third half-angle formula for tangent right there. Tangent of alpha over 2 is sine of alpha over 1 plus cosine of alpha. That's what we see right here. Tangent of alpha over 2 is sine of alpha over 1 plus cosine of alpha. So that establishes that third formula there. And what's nice about these two for tangent is you don't have to worry about the plus and minus sign. You don't have to worry about what quadrant alpha over 2 is in. You don't have to worry about what's positive, what's negative. It's automatically handled for you behind the scenes. And so between these three, if you have a choice, definitely one of these two. And beyond that, usually this one in the middle is probably better because it only has one term in the bottom. And that's going to make it easier to split up into two fractions. Or actually, it'll just make it possible to split up into two fractions if you have to for whatever reason. And even beyond that, it's a little bit easier to simplify than this is right here. Okay, so we will see some examples coming up in the later videos. But anyway, that establishes the half-angle formulas for sine, cosine, and tangent.